All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to use, I'll use a different variable since we've already got A and B. You're going to use your sum of cubes formula. So we're going to have A plus seven B, and then A squared minus 7AB plus 49B squared for your factoring. For the math knowledge question, we have the perimeter of a square is 24 feet. So the perimeter is 4 times the side length, so each side length would have to be 6, and so the area would be 36. We're looking at lesson 43 today, area under a curve as an infinite summation. Hopefully after this lesson, you'll understand how area under a curve as an infinite summation is going to work. So we're going to use inscribed rectangles to find the exact area under y equals 2x on the interval from 0 to 2 by allowing the number of rectangles to increase without bound. So a few lessons back, lesson 39, we did left and right, upper and lower. This one is inscribed. Inscribed is the same thing as saying lower rectangles, and so we're going to do y equals 2x. That is a graph of a line, and we're going from 0 to 2. And it's not telling us n equals any number because we have to make it so that it increases to infinity. So to find the length of each rectangle, we would do b minus a over the number of rectangles, which is n on this one. So the length of each rectangle is going to be 2 over n. And so we're going to draw some rectangles. This isn't going to be all of them because we're going to have infinitely many, but it's going to be some of them. So the first rectangle right here, there won't be a rectangle, so our first one is going to start here, and then the next one would be here, and then here, and then here, and then we'll never actually use 2 because we're coming from the left on these. So we're going to be using the left sides of our rectangles here. So the length here is going to be 2 over n because however far over we went one rectangle over. The next length would be 2, another 2 over n. So 2 times 2 over n would be 4 over n. And then the next one would be 6 over n, etc. And then the last one, we're not going to do 2. I'm going to come over here because I don't have room to write it. It's going to be one rectangle shy of 2, so 2 minus 2 over n. So that would be the last set for our rectangles. So we're going to do for our area, the length of each is 2 over n, and then we're going to plug in 2 over n into our equation, which is 2x. So 2 times 2 over n. For the next one, we're going to do 2 times 4 over n. For the next one, it would be 2 times 6 over n. And then we're going to go, and then the last one is going to be 2 times 2 minus 2 over n. So those would be all of your rectangles that you would do. From there, we want to try and factor something out. So if you look, every single one of them has a 2 out front that we can factor out. And they also are all divided, or they all have a 2 over n. Now this 2 minus 2 over n looks a little bit strange. So if I make it 2n minus 2 over n, then I can factor out a 2 over n, and I'm left with n minus 1. So that's what can replace right here. That's what we'll put there. So if we factor out our 2 and we factor out our 2 over n, we already had a 2 over n on the outside. We factored out the 2 and the 2 over n. We're left with a 1 here. We factored out a 2 and a 2 over n, so we're left with a 2 there. If we factor out a 2 and a 2 over n on this third term, we're left with a 3. And then we go to the last one. We factored out a 2 and the 2 over n, we're left with n minus 1. So that's what you get so far. Now, on your test, they will give it to you, the formula that I'm about to write out. On your homework, they're not, so you'll need to look on your answer sheet to get the formula that I'm about to write. So if you have 1 plus 2 plus 3 plus all the way to m, that equals m times m plus 1 over 2. Okay? But we don't have all the way to m. We have to n minus 1. So instead of m, we're going to plug in n minus 1. And so that's n minus 1, and this is just going to be n. So this whole thing here can be replaced with this equation, or this formula that we just got, n minus 1 times n over 2. Okay, so that's what you're going to do first. From here, you're going to have to take the limit of this expression. So to take the limit of it, we're just going to have to try and simplify it as best we can. So the limit, as n increases without bounds, so that means it's going to go to infinity. So I have 2, 2, 2, that's 8 over n squared. And then I have, if I distribute, I have n squared minus n over 2. So then I can distribute again. So the limit as n approaches infinity. 8n squared minus 8n over 2n squared. Now from here we're going to use our information about approaching infinity. We can divide everything by n squared. So if we divide the first term by n squared, we'll just have 8. If we divide 8n by n squared, we'll have 8 over n. And then if we divide 2n squared by n squared, we have 2. And so if you remember, this 8 over n, as n goes to infinity, is going to go to 0. So this is going to go to 8 over 2. And 8 over 2 is just 4. And so that is the exact area under your curve. So that's how it works. So this is probably a lesson that you're going to want to practice. And it may be good for y'all whenever you get home and you're trying to work through a problem to go back and listen to 1 or 2 of the examples again. This doesn't go away. They show up on your test for the next several weeks. So it's not something you just want to ignore. So I know it takes a little bit of practice on these. They aren't the easiest concept to get, but if you practice with them, they do get easier. All right, so let's look at another one. We want to use circumscribed rectangles. So that means they are outside of the curve. They're going to be upper rectangles, basically. And we want to find the exact area under y equals x squared. From 0 to 3. So that's a parabola. And we're going from 0 to 3. So we're going to make some rectangles. And again, we have an infinitely many rectangles, so I'm just drawing some of them. And we're doing upper, so we're going to come from the right on these. So you don't have to draw this many rectangles if you don't want to. I just drew however many I could. So the length of each rectangle is going to be b minus a over n. which is 3 over n. So this length would be 3 over n, and then we went over 2 of those, so 6 over n, and then another 3 of them, etc. And then the last one is going to be all the way to 3. We are going to use 3 on this one. So for the area, the length of each rectangle is 3 over n. And then we're going to plug in 3 over n into x squared. And if you would rather, instead of writing 6 over n, if you would rather do 2 times 3 over n and square that whole thing, you can. And then for the next one, you could write 3 times 3 over n. That's the same thing as 9 over n. But some people prefer to write it like that. So if you would like to, you can. And then plus all the way to 3 squared. So that's what you're going to plug in. And then we want to pull out something that all of them have in common. So all of them have a 3 over n squared in common. And if I write it like this, it may be a little bit easier for you to see that they have the 3 over n squared. So if I pull out a 3 over n squared, this first term is just left with a 1. The next term is left with a 2 squared. The next one is left with a 3 squared. So sometimes if you write it in this format, it makes it a little bit easier to see what you're left with. Okay, and then the last one, that one's the hardest one for people to see. So we took 3 squared times what will give us 3 over n squared. We're trying to see what do we have to pull out to make it so that it equals 3 over n squared. So basically, that's going to be 9. So if we divide what out, are we going to get 9 over n squared? So we had 9, and we divided by what to get 9 over n squared? Because that's what 3 over n squared is. Well, you'll see that if you just divide by n squared, you end up with 9 over n squared. So this term, when we pull out the 3 over n squared, we're just going to be left with n squared. So that's kind of how you can figure out what you're left with. Now, again, this formula is going to be on the test, but on your answer sheet is where you'll have to look when you're doing your homework. I wish they gave it to you in the problem, but for some reason they don't. So you're going to do n times n plus 1, 2n plus 1 over 6. Okay, so all of this can be replaced by that formula down here. So if I simplify this, 3 times 3 squared is 27, and then n times n squared is n cubed. And then this would be n times n plus 1, 2n plus 1, all over 6. And then we're going to take the limit of this expression as n approaches infinity. And so I'm going to distribute the right side of it. I'll have n times, that'd be 2n squared plus n plus 2n, so 3n plus 1, all over 6. And then we can distribute it again. I'm going to erase this. So if you distribute the limit as n approaches infinity, you'll have, we can actually cancel here. This 27 and this 6 both divide by 3 to make a 2 and a 9. And so we'll have 18n cubed here. And then we'll have 9n times 3n, so 27n squared. And then 9n times 1 is 9n over 2n cubed. So again, you're going to use your approaching infinity limit rule and divide by n cubed. And so you'll have 18 plus 27 over n plus 9 over n squared, all over 2. And then from there, this term is going to go to 0 as n goes to infinity, and this term is going to go to 0 as n goes to infinity. And so you're going to be left with 18 over 2, which is just 9. And so that would be your answer. So again, you may need to practice on these at home, watching the videos again whenever you actually go to do one. They all follow the same concept, so you should always end up replacing something with one of these formulas. And again, those are on your answer sheets. I wrote them there so that you don't have to try and memorize them or keep flipping back to the lesson to look them up. So you have to practice these because they all work very similar, and as you get better, you will get better at working through these by yourself. So your homework tonight, you do get to omit number 5. So make sure you do the other questions tonight for homework so you can go over any questions you have tomorrow.